When you look up at the night sky, you are staring into an immense void filled with billions of stars, yet it is completely silent.
For decades, humanity has been searching for a whisper in the dark, a signal from an intelligent civilization across the cosmos. We have built massive radio telescopes, we have scanned the frequencies, and we have sent our own messages out into the deep. Yet the answer we receive is nothing but the cold, static noise of the universe. This eerie silence is the heart of the Fermi paradox, the fundamental question of where everyone is. We live in a galaxy that has existed for billions of years, giving any advanced civilization more than enough time to explore, colonize, and broadcast their presence.
But to understand why our cosmic inbox is empty, we have to face a terrifying reality about the nature of space, the limits of physics, and the staggering, almost incomprehensible scale of the Milky Way. To grasp why aliens have not found us, we first need to understand how we are trying to be found. Humanity has only been broadcasting capable radio signals for a little over a century. Every television broadcast, every radar ping, and every radio show we have ever transmitted travels outward from Earth at the speed of light. The speed of light is the absolute speed limit of the universe, moving at roughly 300,000 kilometers per second, or 186,000 miles per second. Over the course of 1 year, a radio wave travels a distance of 1 light year, which equates to about 9.46 trillion kilometers, or 5.88 trillion miles. Because we have been broadcasting for about 100 years, our signals have only traveled 100 light years in every direction. This creates a sphere of detectability around our planet, a radio bubble that has a total diameter of 200 light years. Inside this bubble, any civilization with a sufficiently advanced radio telescope could theoretically hear us. Outside this bubble, we are completely invisible, completely silent, and functionally non-existent.
Now, let us place this 200 light-year bubble into the context of our home galaxy. The Milky Way is a barred spiral galaxy of unimaginable size. It spans a diameter of approximately 100,000 light-years. To put that into physical measurements, the Milky Way is roughly 946 quadrillion kilometers, or 588 quadrillion miles across. When you compare our tiny radio bubble to the entire galaxy, the reality of our isolation becomes terrifyingly clear. Our signals have reached less than 1% of 1% of the Milky Way. If the Milky Way were the size of Earth's oceans, our radio bubble would be the size of a single drop of water.
Even if the galaxy is teeming with intelligent life, the vast majority of those civilizations are simply too far away to have received our signals yet.
To them, the Earth is just another silent, primitive rock orbiting an ordinary yellow dwarf star.
Furthermore, the problem of distance is compounded by the laws of physics, specifically the inverse square law. As our radio signals travel outward, they do not stay perfectly intact. They expand, they spread out, and they lose strength. Every time the distance from Earth doubles, the strength of our signal drops to 1/4 of its previous power. By the time our early radio broadcasts travel even a few dozen light years, they become incredibly weak, fading into the natural background radiation of the cosmos. To an alien civilization listening from 50 light years away, our strongest early television broadcasts would sound like barely distinguishable static. They would need a receiver millions of times more powerful than anything we have on Earth just to isolate our faint whispers from the roaring noise of pulsars, quasars, and cosmic microwave background radiation. So, not only is our radio bubble incredibly small, but it is also incredibly quiet.
This leads us to a humbling realization about cosmic timelines. The universe is approximately 13.8 billion years old, and our solar system has existed for about 4.6 billion years. Intelligent life on Earth took billions of years to evolve, but our technological era, the time during which we could actually communicate across space, is barely a century old. This is less than a blink of an eye in cosmic time. For another civilization to detect us, they would not only need to be close enough to be inside our radio bubble, but their technological window would have to align perfectly with ours. If an alien civilization lived and died 1,000,000 years ago, they would have seen an Earth devoid of technology. If a civilization rises 1,000,000 years from now, our current signals will have long passed them by, fading into the void. The terrifying truth is that space is not just vast in distance, it is vast in time, making the overlapping of two communicating civilizations a statistical miracle. We must also consider the concept of the Great Filter, a theory that suggests there is a mandatory, incredibly difficult hurdle in the evolutionary timeline of life that prevents civilizations from becoming galaxy-spanning empires. Perhaps the transition from single-celled life to complex life is nearly impossible, or far more terrifyingly, perhaps the filter lies ahead of us. It is entirely possible that civilizations routinely destroy themselves through nuclear war, climate collapse, or artificial intelligence shortly after discovering radio technology. If this is the case, the galaxy might be a graveyard of dead worlds, each one having broadcasted a brief, fleeting bubble of radio waves before going dark forever. Our own radio bubble might just be the latest temporary flash in a dark, empty ocean. Another chilling explanation for the silence is the dark forest hypothesis. This theory suggests that advanced civilizations do exist, but they are deliberately staying quiet. In a universe where resources are finite and the intentions of other species are unknown, broadcasting your location could be a fatal mistake. If a highly advanced predatory civilization exists, any species that reveals itself through radio waves might be targeted for immediate destruction to eliminate future competition. Under this theory, the night sky is silent because every intelligent species knows that speaking up invites death. Humanity, in our naive enthusiasm, has been shining a flashlight in a dark forest full of hidden hunters. The aliens have not found us yet because our light has not reached them. But when it does, the consequences could be catastrophic. Despite these terrifying possibilities, our search continues. NASA, the European Space Agency, and independent organizations like the SETI Institute are constantly monitoring the heavens. We are looking for technosignatures, unnatural anomalies in the light of distant stars, or focused laser pulses that could cut through the cosmic noise better than traditional radio waves. Our technology is improving every day, allowing us to scan deeper, listen closer, and analyze data with greater precision. We have identified thousands of exoplanets within our galaxy, many of which reside in the habitable zones of their host stars. The ingredients for life are everywhere. Water, carbon, and organic molecules are common across the cosmos. Statistically, we should not be alone. The search for extraterrestrial intelligence is the most profound quest in human history. Every silent night sky is a reminder of our isolation, but also a reminder of our unique position in the universe. We are the cosmos made conscious, looking back at itself, trying to find a reflection. Our radio bubble, expanding at the speed of light, is a testament to our existence, our curiosity, and our desire to connect. While it only spans 200 light-years across a galaxy of 100,000 light-years, it is growing every single second. As long as humanity survives, our sphere of influence will continue to push out into the dark. The terrifying reality is that aliens have not found us simply because the universe is impossibly large. Our signals are painfully slow, and our existence is a fragile spark in the immense, ancient dark. But we keep listening, we keep broadcasting, and we keep hoping that one day, someone, somewhere, will finally hear us. Thank you for watching. I really would appreciate it if you would subscribe, follow, like, and comment, as this helps the algorithm know that people are interested in my videos.